Hello everybody, and welcome back to the conclusion of problem number 3 on page 27 of the workbook. Just to refresh your memory, this problem was about a team playing a certain number of basketball games over the course of a month. And what they told us is that the team is playing at least one game per day and no more than 45 total games over a 30-day month. We're trying to convince ourselves that no matter how the games are scheduled, there has to be a stretch of consecutive days during which the team plays exactly 14 games. And we did a little bit of setup in the last video that helped us to organize the information. We defined the sequence AN, which is keeping track of the total number of games from the first of the month up through whatever day we're talking about. And we talked a little bit about this and decided that what we're really trying to show in terms of the sequence that we defined is that there's some I and j out there so that aj minus ai is equal to 14. If we can show that, then we've proven that there's a consecutive stretch of days where the team plays exactly 14 games. Okay, so we're ready then to go back to the general case. So we're not talking about this particular June schedule here. We're kind of talking about any possible schedule that meets these conditions. Right? So let's just make that assumption clear first here. And see if we can get see how the pigeonhole principle is going to come into this. Okay, so note first that we're really talking about a total of 60 numbers. If we look at the two lists of the two sequences that we created, so there's the numbers A1 through A30, that's 30 numbers, and then there's the second list of numbers A1 plus 14 to A30 plus 14. That's also a list of 30 numbers. Put those together and you get 60. Okay, so let's list those out. Okay, and yeah, there are 6 numbers, but let me change the wording a little bit here. So note that those 60 numbers, these 60 numbers that I just listed, there's a range of values that they have to be in. Okay, and we can see that if we look up at our work. So the first 30 have to be between 1 and 45. The second 30 have to be between 15 and 59. So if you think about it, all 60 of the numbers have to be between 1 and 59. We can see that from the inequalities. So finishing that thought, all of these numbers, all 60 of them, are between 1 and 59. That's starting to sound like the pigeonhole principle. We have 60 numbers on our list and only 59 places for any of them to land in. Okay, so in the language of the pigeonhole principle, we have 60 pigeons and 59 holes. Okay, so our conclusion then is that there have to be 2 numbers on that list of 60 that have to be equal to each other by the pigeonhole principle. Okay, now here comes kind of the last step of the argument. This last step is a little bit tricky. We want to consider what might 2 equal numbers look like on this list. We're saying that out of these 60 numbers, there have to be at least 2 that are equal. Okay, well, if I can just scroll back a minute, we made the observation up here that if we look at just the first 30 of those numbers, none of those are equal to each other. Okay, because A1 is less than A2 is less than A3. Those numbers have to increase by at least 1. So there are none of the first 30 numbers that are going to be equal to each other. And we could make the same comment about the last 30. Okay, the A1 plus 14, A2 plus 14, A3 plus 14, that list is increasing, so none of those 30 numbers can be equal to each other. So the only possibility then, if there are two numbers on the list of 60 that are equal, the only possibility is that one of the first 30 numbers has to be equal to one of the second 30 numbers. Okay, let me see if I can write that down in a way that makes sense here. So we observe that the first 30 of those numbers are all distinct. That's just the mathematical way of saying that they're all different. And the second 30 numbers, A1 plus 14, A2 plus 14, all the way up to A30 plus 14, those are also all distinct. Okay, and so the only conclusion, again, is that there's got to be one of the first 30 numbers being equal to one of the second group of 30 numbers. We could write that down by saying that one of the AIs has to be equal to AJ plus 14 for some I and J. We don't know which one it might be. Okay, but look what that says. If we take that equation, AI equals AJ plus 14, and just subtract AJ from both sides, that gets us exactly where we wanted to go. AI minus AJ is equal to 14. And by the observation that we made above, when we were analyzing the specific case, that's exactly telling us that there's a stretch of days, consecutive stretch of days, where the number of games played was exactly 14. Okay, let's put that into words. Okay, we can even nail down the days in terms of the I and J by saying between the J plus first and the ith days of the month. Whatever those two numbers might be. Okay, and we are done.